everything now at this point. It's just kind of you can't like clam up. Just try to keep rolling with it.
Yeah. Okay. So we're live now. Okay. So like I'll give it a couple seconds because usually people don't like join in at the start. And I'll just wait for like a couple people to join in. Um, let's see. Okay, so welcome to the few people that are here. Dusty's here with me as well, and we want to talk about strong emergence or emergence in general. And the basic premise that the idea of emergence is built on is that at the most fundamental level in our universe, you could arguably, some people don't argue this, but you could arguably describe everything in terms of these fundamental constituents or these fundamental particles. And these are the smallest kind of units of reality. It could go deeper, but as far as we could tell, we don't know whether it goes deeper or not. So as far as we could tell, this is the lowest level of reality. And then all phenomena which exist in the universe are conceivably constructed from these fundamental constituents. And the question we want to ask is, if you just knew about these particles, about these constituents, would that tell you, would that give you enough information to describe all phenomena that could exist in the universe? And the argument that I posed is that no, actually. And there's a lot of reasons for this. One reason being that of strong emergence. And so we were discussing the nature of strong emergence. And this is kind of like a topic that's not fully articulated like in the writing, because there's a lot of debate about what strong emergence entails and what it actually means. For example, you have Chalmers, who's a very famous philosopher of mind, who would say that strong emergence is any case of emergence where, for example, like he would cite this example of consciousness, that consciousness is an example of strong emergence because there's no way conceivably to understand consciousness in terms of matter. But others, for example, George Ellis, who I base a lot of this presentation off of, would say that that strong emergence can be claimed in any case where a higher level phenomenon has a downward causal effect upon the lower constituents. Now, the question Dusty asked me a question in our Discord server, or posited a point about the possibility that transistors and the logic that you can perform with transistors might not be an example of strong emergence. Is that right, Dusty?
Yeah. Hi, I'm Dusty. I've been buddies with T-Pan for a while. We are constantly talking about different ideas. Generally philosophy, but also psychology, and those things overlap. And the concept of emergence has come up in a few different cases. And he's working on a video trying to uncover and just understand emergence in general a little bit better, and maybe make some conclusions based on that. And what other relevant thing I think is that you had brought up strong emergence when you were making a video about free will. Mm-hmm. And so this concept crops up pretty much everywhere. It's just like trying to nail down like the different forms of it and what it means and how it functions and everything is actually really tricky. And what you said I think is really true, is that like there really isn't consensus on what strong versus weak emergence even is. Mm-hmm. And so like we're going to try to just figure that out a little bit better. And I don't know. I mean, so if we're not even operating on the same definitions, then we're not going to really get anywhere, obviously. So
yeah.
like,
well, what I'd want to do is convince you that. So you brought up the example of red. So like let's yeah. So like a mental experience like the color red, and that's an interesting example because like there's it seems like. Maybe this might come down to like we need more words. Like maybe emergent and weak emergent and strong emergence aren't enough. We need something like super strongly emergent, or like even like different degrees of emergence. Because the color red, it's like I can't even describe to you what redness is. Like I just have to trust the fact that you know what I'm talking about. I can never transfer the experience to you. I can never explain what it's like to somebody who's never seen it. And furthermore, it seems like impossible to even derive it from physical processes. And so something like that. Yeah, go ahead.
Let me cut in quick. So I like, this is where my mind kept coming back to when I was thinking about how we were going to talk about this. Mm-hmm. So the idea of reducibility like seems to be at the base of all of this. Like can we reduce something and then mechanistically understand, okay, this is how it works. But even just not, like, the question how it works is kind of complicated, because imagine and we've had conversations about this too, but like if we created a biomimicked brain and the brain like had an experience of red, okay? Would we have like reduced it? Would we have figured it out? Like, would that make it then weakly emergent and not strongly emergent? Like, even if like the actual qualitative experience, like from a consciousness perspective, like we don't understand how to explain that, like you're saying, like the actual experience of it, but just okay, when we hook things up the right way, it produces red. Like, does that make it weakly emergent, or is it still like technically strongly emergent because we can't explain the redness itself? Do you see what I mean?
Yeah. So this is a problem I came up with when I was discussing free will in the first place, where I think I kind of I used the wrong terms, because like it's because a lot of the responses that I got were like people saying, "Are you sure it's impossible to explain, or is it just that we haven't like tried hard enough to understand the mechanisms at the lowest level?" But what I'm saying, but what George Ellis is implying, or suggesting rather, is that sometimes like that when any kind of lower level system gives rise to something, okay. It's a question of whether we consider that something a new entity, or is it just like the sum of its parts. Now, I think weak emergence is when you can confidently say that it is just the sum of its parts. Okay, but strong emergence is this new entity that now exists, and we can't just think of it in terms of its smaller parts, because it in of itself constitutes a new kind of being. And we know that it's a new kind of being because this new thing, like I would say like an atom is a good example. I mean, nobody's proven that this is strong or weak emergence, but like most physicists would say that it's weak emergence.
Oh, you just had it. Go back.
Do you see it? No, the atom that I have here are the neutron protons.
It's funny when you keep. Oh, I think you know what it is. It's a glitch. You're showing the right thing, but I'm okay. Now it's showing. Yeah.
Oh,
like
wait.
when you yeah, I keep seeing the most basic particles, the subatomic particles.
Oh, okay. That's still on your
yeah,
screen? What do you see now?
Yeah. I see you switching through, so it'll show like what you're showing for a second, and then it goes back to the originals. But it's fine. I know what I can just follow what you're doing.
Okay, so
I just
hopefully
got confused.
yeah,
I got confused. I thought you were like cycling all the way back through to like the same thing over and over again.
Oh, okay. No, yeah. Okay, so what I'm trying to show Dusty was, hopefully you guys are seeing it on the stream. If somebody wants to confirm that,
Yes, please.
Yeah, I'm showing the picture of the atom, and then the question is like, okay, you can see that the atom is composed of smaller parts. It has electrons, it has neutrons, protons. But is that all there is to an atom, or is it, now that this composite object, we need to think of it as like a new thing? So regardless of what its constituents are, is this a new kind of entity? And we can say that it is a new kind of entity if the smaller parts are for some reason affected by the higher level, okay? So like this higher thing exists, and for some reason the parts aren't exactly acting the way they normally would, okay? And this would have to be, so if think about it logically, Dusty, this would have to be, no matter what, a case of strong emergence, because there's no way for me to use the fundamental math to get to this phenomenon, because the fundamental math is, when this phenomenon appears, is like broken.
It emerges.
Well, yeah.
It becomes its own thing, like you're saying. It becomes its own entity, which then has a top-down causal effect.
Exactly.
Yeah, so I mean, we're dancing around, but I think we're using different, like he's using a different terminology and like way of defining like strong versus weak emergence. Then I question like, well, what is a good example of weak emergence then? Because it just
that's a very good question. Because every time I try to like I do try to come up with examples of weak emergence, and like it's actually very hard to prove that any phenomenon is weakly emergent. Like even so right now, hold on, what do I have on my screen?
Well, you see, like, all right, like it seems like people are either on one side of this, like, and I'm on the opposite side of you. Like I see it, I see like the burden of proof being to actually prove strong emergence, and you think it's weak emergence, and like
because weak emergence is a much simpler thing to prove. Like you just have to show, if I follow this chain of mathematical reasoning, can I get to this phenomenon? Okay,
Yeah. So,
so
and I mean, like even all the way down to something that seems like intuitively strongly emergent, like the color red. Like if you just arrange the cones and like have the electricity and the light go like do this specific pattern and way of being systematized, then it will produce red. You know what I mean? Like there's nothing like, I mean, so if we want to make it the definition that you said, where it's more than the sum of its parts and it has a top down causal effect, then yeah, it's totally strongly emergent. But then the question is, then what's weakly emergent? And because everything is that way, that's emergent. You know what I mean?
I
So
mean,
like
I don't know if everything is like that. I just haven't seen any convincing cases that it is like that. But there are examples. Like, I mean, physicists, the reason they're so confident in the idea of reductionism is because reductionism has been successful in some cases, and then the problem is that they're like, okay, well, it's successful in all cases, which I think both of us agree isn't necessarily the case. I mean, yeah, I should probably look into more specific examples of weak emergence because, I mean, there's also another
okay,
philosophical.
all right.
Yeah, go ahead.
Just to like, I think that, I mean, I struggle to find any example other than conscious qualia of being irreducible. Like I don't see like like I'm saying.
What do you
even
mean
if
by
we can-
irreducible? Like, I guess you were describing it earlier, but if you want to like discuss it in a bit more detail.
Well, just like break the Goldberg machine down to its basic parts. See each step in the process, and then the process is what produces the effect. And like, and every single step is observable and predictable and understandable in some sense. And like, there's no like, oh, you know, surprise, like now this happens. But so like, and but that's relevant because I'm pretty sure in your free will video, you were talking about how they were making computer models, or they can do different experiments where they can have effectively the exact same starting scenario but end up with an unpredictable result. And so like, so that seems irreducible too, you know, to an extent. And like, then the question becomes like, is it reducible in the sense that in a percentage of cases this result happens, in a percentage this happens? And then like, I even think about it in like natural systems, where you've probably heard of like the crab effect.
I haven't.
Where well, the crab effect is that crabs are divergent evolution, or what is it, convergent evolution. So like multiple different trees will all convergently evolve into crabs. So like there have been multiple trees that have resulted in that. So like my point is, okay, you start out with like, you know, in some sense the same organism, and then like some percentage of times it turns into a crab, and some percentage of times it turns into, you know, but each same environment. Okay, so like maybe that would be a proof of irreducibility and thus strong emergence, because you've reduced it down to its basic parts, but it's still unpredictable. Does that make sense? I mean, maybe I wasn't understanding what you were saying, but like I thought that was kind of what you were saying, and
No,
that like
I
certain
think
crystal, like even crystal structures and like you know, lots of different natural processes act this way, where it is impossible to predict from a like a previous state.
it's impossible to predict, or it is possible.
It's impossible to predict, like depending on the type of and the complexity of the system, and then like whatever the result is some type of emergent. You see?
Yeah. Let me get to this slide where we talk about crystal structures, just so people have some context. Yeah, I see what you mean. Okay, so I can clarify one thing, because the term irreducibility.
It's really thorny, yeah. So
Yeah.
we got to figure that one out.
Well, so there's one sense in which it's meant when people are discussing emergence that like, so some property that anything has, if it's missing like a fundamental component of that property, if it's missing a fundamental component,
okay.
it just doesn't have that property. Okay, and like the example, the easy example to understand that I always put forth is like the state of being alive. Like you right now are alive, I'm alive, so we're both aliving, we're both living. And like if you take away your heart, it's like suddenly that's gone, and suddenly you're now just in another state of being dead.
Yeah, like taking the engine out of a car. It no longer functions or does the same thing. Like, although it's a good question, like when does it cease to be a car? But
when does
either way, it loses the property of being able to drive.
Yeah, okay, that's sure. But with the living example, it's like a very clear cut. It's it's either dead or alive. I mean, I don't know if you agree whether it's a clear cut, but I think that in my opinion, it's a very interesting thing that like if somebody's dead,
It's a clearer cut. It's a clearer cut than the car example, but yeah.
Okay. Yeah,
Yeah.
but like if you remove certain components, it's like the entity that we're talking about no longer has the property of living. Now, like an example that I saw in a paper was with respect to proteins, and specifically enzymes. And enzymes are composed of multiple proteins. And what they showed was that like if you don't have the right concentrations of certain proteins, like you just don't get the property of the enzyme. But then if you get it at the right level, the property suddenly emerges. So that's what they meant by irreducibility. But I think what you mean by irreducibility is probably more relevant to what we're talking about, because that paper is even like it's arguably it's in that paper they don't even like they don't define strong emergence in the same way. So again, we're getting to that issue of definitions. But I think that your idea of irreducibility is interesting because I thought like so for example, if we talk about a computer, I thought the whole point of like a computer and putting things through transistors was to actually black box the system, as in like you kind of conceal it. Or I mean, you can obviously correct me if I'm getting this wrong, but you kind of like you put it in a black box, and then whatever you get at the other end is just what you happen to get. And like the whole point is that you don't have to like go through all the little details of what happened.
No, so that's AI. What you're describing is AI. So a traditional computer is predictable. It's really just a series of NAND gates that are arranged in a clever way and are reconfigurable via software. And software is basically like what's the best way to describe this? Like the peg game where you like drop a ball down and then it like hits random pegs and then it'll hit a spot in the bottom. Rearranging software is like changing those pegs in a clever way such that you make the balls fall from the top such that they do a useful computation. Okay.
Right.
And that is like it's discrete. Okay. Like you can, and that's why like I had a problem with him saying that it's strongly emergent, at least from what I'm understanding. Now I'll say that like, yeah, we have imbued like literally sand, because that's what a processor is. It's silicon, right? We have imbued sand like with, in some sense the power of logic, but logic itself is really just it's just structural. It's like I'm saying, it's like a peg game. It's like it's just deductive. It just is the nature of shape.
And you would say that logic itself is nothing new, like it kind of already existed?
I think that language, it's funny because like logic is basically the language of math. Like it's like mathematized language. Okay. But like language itself, I would say would be a better example of strong emergence than logic language, because logic language is so deductive, whereas language, it almost seems like we do, like it is inductive in that we create like some type of new meaning when we create words.
Right.
And like I haven't thought a lot about that, but like that's just like my intuition.
Yeah.
I just thought it was ironic that he was driving hard on this logic thing when I just see logic as being the shape, like it just is. Like we didn't actually create like the top down like effect that he's talking about, other than just shaping sand into a fancy way, so
Okay.
like.
So
Yeah.
I get what you're saying. I think what I'll try to do is like maybe run down the argument a little bit, and then we can respond to it piece by piece. But one question though, like okay, so I could write logic to be whatever I want it to be, right? Like it doesn't have to be logical inherently. Like for example, I could write a program that just anytime you feed in any input, it just gives me the number 5. Like no matter what input it takes, it gives you the number 5. And there's nothing inherently logical about it. It's just that I've arranged things such that this is the output of this program. So wouldn't you say that there's nothing like inherently, there's nothing in the structure of the universe that provides for that. It's that something that's being imposed by me and by like the way I've structured the logic. No?
Well, you're just calling something that isn't logic then, in my opinion, because like
yeah, but a lot of programs are like there's nothing the logic you impose upon it is to get a result that you want, but it's not like there's nothing it doesn't like it's not like inherently, let's say, true or false. Like I can get the wrong result from a program if I program it to give me the wrong result. But the point is that like it's my programming that's controlling it. No.
Yeah, if it's just illogical. It's like that's my point. It's like logic.
But even if it is logical, it's the same thing. No.
Yeah. So I mean, I see what you're saying, and that's why I'm saying in the sense that like sand doesn't just spontaneously make itself into a processor. No, like like we came up with and like systematized like the idea of logic and understand really what it is it's just the understanding that 2 + 2 = 4, that you put 3 beers in the fridge and like you open the fridge and there's only two left. You don't think, oh well, logic was different today. It's like that. That's not how logic is. Like logic just is logic. It is just the nature of space. And like, but as far as like the top down like efficacy thing, which I think you're talking about different things, and I think that he's talking about different things, but he wants to talk about the same thing. It's like, yeah, like we as human beings like have, in my opinion, discovered logic, and then just we do what humans do, and we take our hands and we shape the world into what we want that's actually useful, okay? And like when it actually is useful and when it actually like produces results that we want and that are quote unquote logical, then we call it logic. And if it isn't, then it's illogic. It's not logic. It's it's chaos. So
Right, but I mean, like, would you say that like there's anything inherently logical about what happens in a video game? Like, it's not like the logic works itself out through the circuits, but like there's something over and above the circuits that's causing the circuits to kind of take a certain route. Let's say.
sure, our
And
consciousness,
that
like
yeah. But even if we so one of the things about this is that like any phenomenon that involves consciousness, for example, economics, well, like we can instantly take it to be strongly emergent, because it's involving things that are literally non-material, like the value of money. Is an example I always cite. It's like the value of money exists in our heads, in our consciousness, not even in our consciousness necessarily, but like in the mental or abstract value that we attribute to it. So something like economics must be strongly emergent, but we can talk about that a bit more later. But apart from like the consciousness of me writing a program and then me imposing that program upon logic circuits, I think that I think there's an argument to make that logic itself, like. I mean, like, I don't know. It's a question of whether logic existed in the universe inherently, and I guess it would have to for the universe to be consistent to any degree.
No. So like logic, like in terms of
Like Boolean
like,
logic, like literal. Well, let's get like to the most like abstract level, like Boolean logic of two values and then these different logic gates.
Yeah, I mean, it's the 3 beers in a fridge example. It's just like things don't, and it gets ironic because you get down to the deepest level of quantum physics and like apparently things pop in and out of existence, so that gets a little bit tricky. But like for the most part, like from a classical perspective, it's like things don't just disappear. Like we have consistency of matter. What you know what I'm saying? Like things don't just evaporate randomly. Like 2 + 2 = 4, and if you use math correctly and logic correctly, then you can have predictable results. Because if you use it incorrectly, then you just don't have predictability anymore. I mean, just in the same way that it's predictable that if I jump off a cliff, I'm gonna fall and die. It's like there is a rational like objective reality, and logic is just us systematizing the way that it interacts with itself.
Okay, yeah. So I'm still a bit like hung up on the like if I make a program and the program, let's say it'll. How do I put this? Like it was the example that I was saying earlier. Like you were saying that it's just not logical, but what I'm saying is that like it's something that I've created that couldn't have existed no matter what. Like it couldn't have just spawned out of the universe if we were to follow just fundamental physics. It's something that my mind has created and then imposes upon these circuits, and then the circuits have to obey this higher thing. Like, would you say? So hold on. So let me grab the. So on my on the screen right now, I have the diagram that that starts at the highest level, being high level code, like for example Python or C++, and then it chains all the way down to transistors. Now, I can briefly talk about the standard argument for why this must be strong emergence. Is that if it were weak emergence, you would be able to take the equation that dictates how electrons flow through circuits. Which itself is like a very complicated equation, but in theory, you could take it and then get the results of where the electricity will flow just from that information alone. But it's impossible because you have higher level code which exists in a kind of abstract space. So I would say that George Ellis would consider code to be abstract. and the logical code that we write with a language like Python to be like in an abstract domain. It's not material because it's you know it's the language that it's the symbols that we've designated to mean these things. So it's not material in that sense.
All right. I think that you're mixing. I think that he mixes up the idea of logic itself and just programming. Okay,
Well,
and the interaction of human beings with technology and writing a program and interacting with a computer, like that whole system and thing like happening, I think that that's strongly emergent. But the idea that logic itself is strongly emergent, unless you're talking about like the field of logic, like the like you're saying, the abstract space, mind space of like the philosophy of logic. Now, here's the thing, like there is still like a lot of debate actually on second order logic, which I don't know a lot about. But as far as like first order logic, it is like 2 + 2 = 4. Like it isn't debated. Like it is just the nature of things. And like to say that logic itself is strongly emergent, I like, unless you're talking about like our ability to wield it and like have it as a psychological like framework, then I just disagree.
Okay, so he's talking about both. So he's talking about he talks about
although here let's just like, okay, let's just ground ourselves really quickly. I mean, in some sense, like it is strongly emergent in that nothing about quarks like tells you anything about how. Although maybe it does, because it still operates in space, like, and it is just a particle. I mean, like, you can imagine, like, if they wouldn't interfere with each other, quarks, like, working like your water computer, the water computer example that you brought up. And, like, that's why I just keep saying that, like, it's just about space. And, like, and like, when you bring up the example of, like, using just how electricity flows through a circuit, use that algorithm, and then you wouldn't be able to predict where it's going to end up. You can predict where it's going to end up if you know the actual state of the computer, which is dictated by the program that you write.
So yeah, so this is what we were talking about earlier, because it was often conflated that like unpredictability was strong emergence, but it's not unpredictability. It's unpredictability from the lowest level. It becomes predictable if you have information from the higher level. So if you could see what that code is doing to change, to turn on this transistor and turn off that transistor, you would know where the electricity is flowing. And that's the whole point of his argument, is that like the lowest level can never tell you what's going to happen, how that system's going to evolve. If you take information from the higher level, if you could see what the code itself is imposing upon the system, then you have a complete picture. So you need to look both from a bottom-up perspective and a top-down perspective. The bottom-up perspective is insufficient.
Got you. Okay, yeah. I just have the problem with saying it's logic. It's computer programming. Like you can't. I mean, I still want to without understanding the programming.
Right, but I would say, okay, so let's go so right now I have on my screen the example of the water computer, which is, I think, just like a basic adder that takes in two binary numbers and then gives you an output, and it uses water. Okay, so this is the exact same logic, the exact same logical structure being realized in a completely different system. Now, the multiple realizability thing is also kind of, in my opinion, if you think about it, it does make sense that anything that can be multiply realized, so like realized using different means, must itself be strongly emergent. So what I'm saying is, the Boolean logic that's being operated by these little containers of water is itself strongly emergent, because it exists on a different plane relative to the parts. Like, you know what I mean? Like you've arranged these. So if you're thinking about transistors again, you've arranged these transistors so that they happen to produce the outputs that you want. But like that arrangement itself is like a kind of new structure. It exists on a higher level, with gates like and, not, or. Now at that higher level, like. Did you see what I'm saying though? Like
I do. I see what you're saying.
It has to exist on like a different plane relative to. Yeah, go ahead.
It's a little bit of a verbal dispute, I think. I disagree with using the word logic, but I get the concept.
So what would you replace the word with? Like what would you say what's a better word that like or captures what I'm trying to express?
Human fuckery.
No, but I don't even see it on that level, because you can throw in like the human mind into anything and then it becomes strongly emergent. What I'm saying is, like, if somehow, like, just somehow, like, out of the Big Bang, like, transistors appeared, right, and they were arranged in like a basic logic circuit, that the structure of the logic that gets outputted from, or that's contained within the transistors, you have to think of that as being strongly emergent because of this downward effect. So, like, even if the human mind was absent from this, from a transistor, from like a digital logic, what would you call it, like a scheme, digital logic, whatever you have, where you arrange.
Because it has a new characteristic.
Yeah,
Because it has a new characteristic.
But I would say that the new characteristic. So you're saying it's not logic, but I'm saying it is logic, because the new characteristic is the way the transistors are arranged, which gives you logic. So the logic itself must be this new thing, but you're saying that it's not.
Yeah.
Or I guess you're saying that, like, it's not new because logic kind of has to inherently exist.
Yeah, it does. Well, in the sense that, like, two rivers, meet together and become one, and it's just an adder, like it just doesn't exist. Like, we can look at it on a planetary scale, like, and think about it that way. And, like, planets don't just blip out of existence. Like, they exist. Like,
well, but can I ask you, like, do negative numbers exist, or like do irrational numbers exist? So the mathematical domain itself, like, mathematical abstraction involves things that aren't, like, true in our universe. Like, negative numbers, like, I mean, you can ascribe, like, for example, like, temperature, like, to having a negative value, and that's useful for humans. It makes it easier to talk about the temperature, but, like, as a concept, we've kind of invented it, so it has to exist in an abstract space, right? And isn't it possible to get, like, logical circuits to give me answers that aren't, like, inherently mathematically true, but are true given the conditions I've imposed upon it? And couldn't you argue that this in and of itself shows that the logic, like that the logic that I'm imposing upon it must be of a different order relative to the inherent logic of the universe that you're supposing exists?
It's definitely to a different order. Like, just on terms of scale, because like we've said, like, a processor doesn't just pop into existence. Like, it is on a different scale, and thus this is a mind trip.
No, it is. It very much is. Yeah,
it's pretty tough, because then it's just like then you get back to, like, the strong versus weak emergence. Because I generally do agree with you. I'm trying to wrap my head around this right now.
Yeah, I mean, this is the reason I've been so obsessed with it for such a long time. Is that, like, it's
a good question. It's actually, like, it's relevant, and it hasn't been solved. Like, I don't, like, not in a satisfactory way that I've seen. Like, I see people, like, say things that seem to be right about it, but
I mean, even this transistor argument that Ellis brings up doesn't convince you. I mean, I can go through it again if you want.
No, well, I just don't like his terminology. I think that's my problem. I think that logic, like, again, I think that logic is inherent to the universe, like, in that it's a property of space. And, like, to say that you can say that humans invented the field of logic and mastered it and then have imposed it on the world in order to create emergent things. Okay. But to say that logic itself, like, it's a verbal dispute. I just, there has to be a separation, like, logic as an invention and logic just as a structure.
Okay, so let's forget about logic, and just because, hold on, let's see if this makes sense from, so this, if I can reiterate for the audience, this argument, so anytime we talk about emergence, we could talk about different levels of emergence. It's not always easy or straightforward to identify the different levels, but the different levels that are given to us by Ellis he starts with the ions and electrons, which is, like, the lowest level. Straightforward. What do electrons do? They follow this electron Hamiltonian, which is very complicated, but in principle, deterministic. Well, it's actually not deterministic because it involves quantum mechanics, but no worries. In a general sense, is deterministic. And then you can talk about just, like, the general flow of electrons overall, and that can be, like, your next level. Okay, so the electrons as a whole, as they're moving through a circuit or moving through a wire. And even the way electrons move through a wire is not straightforward from the lower level. Because pure metals, I mean, jump in, Dusty, whenever you feel like talking, because you know about this more than me. But pure metals, such that electricity can flow through them smoothly, don't exist in nature. We have to make them and refine them. So even this property of metals to conduct electricity is arguably emergent in and of itself. But anyways, level 2 is just the electrons in general. Level 3 is when you get into the crystal structure of the semiconductor. And so this is where things get complicated, and the physics gets really complicated. But suffice it to say, if we go one level higher, we have the transistor. So I would say that Ellis would probably say that transistors are strongly emergent, because you have this complicated system of these different crystals, these different silicon crystals that are doped with either boron and phosphorus, and these give you new properties such that the electrons will behave differently within this system. So what do you think about that? Would you say that transistors are themselves strongly emergent?
I think that, well, they're certainly emergent, and then
Yeah.
we just now we circle back on this question of like what is weakly emergent then, if that is the definition of strongly emergent.
So yeah, I started a thread about this for a little bit, but then I got off topic, as tends to happen with my ADHD brain. So it's actually possible that like the way to define weak emergence is just going up the scale. Right? It's just like if I can show that something is composed of smaller things, it's weakly emergent. It only becomes strongly emergent if that thing then has a downward effect. So you can say that so what I'm trying to say is that like we can differentiate between weakly and strongly emergent, and this is how some philosophers do it, by saying anything that's upwards is weak, and then anything that also has downward effects is strong. So if you go up any level, so for example, we don't even have to start at the lowest level, because we can talk about emergence within contained systems. So for example, like if I what's a good example? Do you know what's a really good example? The Game of Life. You know the Game of Life, right? Conway's Game of Life?
I actually don't know.
Oh, okay. Oh, man, you need to look into this. It's super fascinating. It's super simple too, but it's a basic computer program where it's a game that runs itself. So it simulates itself, and all it is are a bunch of cells on like a grid. Okay, and some of the cells are either alive or dead, and you set up which ones are alive. And there's like rules for which cells come to life and which cells die. Okay, and these rules are really simple. These rules are really simple. It's like if you have 3 neighbors, you die. If you have 2 neighbors, you live. Something like that. So really simple. Okay. Now in this game, you can get the cells to produce like a wide variety of behavior. Some of them are really interesting and like really strange, and like you're wondering like how is that even happening from these simple rules? But it is happening. The simple rules can give rise to like a huge amount of behavior. Now, just like keep in mind that this isn't fundamental physics, like I'm not like talking about the standard model of particle physics. I'm talking about like the most basic mathematical arrangement. So like it's a lot simpler to study something like this than studying physics, where the math is really complicated. And what I was saying earlier is that you can have emergence in a system like this. So like you can have emergence in a relative manner. Like it doesn't have to be from the fundamental physics upwards. It can be like from a simple math system upwards. Okay. Now in the Game of Life, there are many examples of weak emergence, and these are basically just any kind of arrangement of cells where you look at it and then you look at the cells and then you input the rules, or you think about the rules. Like I say, and for each individual cell, you decide, is that one going to live or is that one going to die? And then if you can do that and then successfully predict what the next generation will look like, that's weak emergence. So simple. But researchers have shown, several now independently, that you can create strongly emergent phenomena inside this game, where if you look at the arrangement of cells and then try to predict what's going to happen just based on the simple rules, for some reason you get the wrong answer. And it seems that the reason is because you get these bigger structures, which can then influence what's going to happen later down the line. So it's kind of eerie in that way. But do you get what I'm saying when I say like you can see emergence within a contained system?
Yeah, and also like the top-down effect is key, like to what he's talking about. And I'm trying to think of other examples. Like, would you say that atoms have a top-down effect on quarks? like on subatomic.
Possibly. Yeah. Well. So quarks. That's an interesting example. The quarks are like the lowest level, and then a hadron, like a proton, is composed of multiple quarks, right?
Hmm.
So researchers to date have not been able to prove this as an example of weak emergence. So it should be like the most straightforward example. But I mean, obviously the math is really complicated. So obviously they're still working on it, and they haven't yet to prove it. But they could prove it in the future. But it's possible that like for some reason when you get three quarks together like that, that something different happens. It just unlocks like this new level of reality where now the quarks are having a different behavior. So yeah, it's possible. It's definitely possible that atoms themselves can change the way quarks behave.
Yeah, like a crystallization type thing, where like at the start of the universe, they happen to take one form, and then we're in one emergent like timeline or like possibility where atoms have forced quarks to behave in a way which creates more atoms or whatever. Because I'm trying to think like of an example of weak emergence where there is no top down effect, because like fundamentally it's actually hard, because even in the example you were saying with the game of life, it seems like the inactive or predictable life forms would still be like in some sense like having a top down effect on their constituents. So it seems like it's like the type and extent of that control like varies widely, so it's not like a one or a
So
zero in that regard. So
yeah. So let me think. Oh, so let me like try to clarify something about weak emergence. Is that like let's say for example that consciousness is strongly emergent. I mean, I think we both agree on that. Okay, so I can take consciousness and let's say so let's think about consciousness as like multiple domains of mind. So I have my perceptions, and I have like my emotions, and then I have my cognition, my thoughts, and then so these are different like let's say aspects of consciousness, and together they give you consciousness. So what you could do theoretically, assuming that weak emergence as a concept does actually make sense, is like create a system using these components. Okay, so I have these multiple strongly emergent phenomena, but then I can show using these components alone, just forgetting the bottom levels, that there are either phenomena which are weakly emergent from this or strongly emergent. So there's like a relative thing going on. And then if you can get like a brand new phenomenon from these components, then that would be strongly emergent. But like any phenomenon that happens that just involves those parts, which I guess doesn't have this top-down effect, is weakly emergent. But you see what I'm saying? Like it doesn't you could create a system that involves strongly emergent phenomena, and then show within that system there are weakly emergent phenomena or strongly emergent phenomena. It's just it just comes back to that same that problem that you mentioned earlier. What's an example of weak emergence?
well, yeah, I'm like going around in a circle here, trying to parse this out in my brain right now, and like I do see my error in how I was interpreting the word irreducibility, and I had read like that was just like a training type thing, because I hadn't like like positioned my brain to think about it.
Well, I think the concepts you were bringing up were like relevant for sure. It's just like the way
they're relevant, but it's not like the right usage of the word. I see what you mean. It's like what it does seem like the processing or perception of the color red. I do like that example. Like it does seem like it would be irreducible, in that there must be like a series of necessary components in order to do that, and if you take any of them out, then it will not work. And then something else that's interesting is like what extent is that a gradient as well? Like can you take some out but it still does the same thing, and at what point does it not anymore, and or will it do like the same thing but to a lesser extent, or like
if assuming that that irreducibility is a feature of strong emergence, the answer is no. Like it can't do it to any extent without all of the components. Like that feature is just not existent without all of the components. So yeah, that's the answer to that. That's what they mean when they talk about irreducibility in the literature. Although like these are still open questions and they're still researching.
So maybe a weakly emergent thing would be something which you can take some of the parts out, but it still functions in the way it needs to, or like is defined to.
I mean that sounds like a suitable possible definition.
I don't know. It's.
Yeah, but like weak emergence in principle makes sense, right? Like you just the way I thought about it originally when I was encountering all of this is like just purely mathematical. Because like I can, so let's discuss this a little bit. I don't know for sure if this is even relevant to strong emergence, but this is where my brain was going when I was researching it. Where like if you have a mathematical system, like are you familiar with like Euclid's postulates, like the five postulates of geometry?
You're gonna have to refresh my memory.
Okay.
I know what you're referring to, but
Yeah. Like, well, like in general, like math always starts with like axioms. Like you just assume these things to be true, and then what logically follows from these things that are true. So like Euclid's five postulates are like you can draw a straight line indefinitely, all 90-degree angles.
Euclidean geometry.
Exactly, Euclidean geometry.
Like what I was basically saying about logic is that logic is Euclidean geometry. Like it is in that category. You know, like we like we can make the separate category of logic in terms of like the abstract thing that humans created. But you know, like fundamentally, like that thing is just like mastery of the Euclidean geometry.
Yeah, but this is where I disagree because there's nothing inherently true about Euclidean geometry. It's just a bunch of axioms that we came up with, and they could be true in some context, but we've also shown in some contexts they're not true. So like even Euclidean geometry,
like in quantum context.
Well, in quantum contexts, Euclidean geometry appears to be true. It's when you talk about gravity where it stops being true. So yeah, like it's a comparison between these contexts where like you have to impose different rules.
It's interesting because like you were talking about when you were talking about producing something like within the computer. Have you heard of non-Euclidean games?
No, is it like a game company?
No, it's like the concept of the game. So what the hell is it called?
Here, I can look it up.
Outer
Worlds?
No, not Outer Worlds. That's an okay game, but it's a totally different thing I'm talking about. It's something like that. It's damn. It's a non-Euclidean game, and Worlds I'm pretty sure is in it.
Okay.
Outer Worlds, or I don't know. That's the other one.
Okay.
But the whole point is that like it has non-Euclidean aspects to it. So like you look at something, and when you look away from it, it disappears and goes to a different spot. Okay, which is kind of like not. It's like pseudo quantum, like they call it like quantum, like non-Euclidean gaming. Okay, but it is interesting that we can create like a non-Euclidean, like non-logical like scenario in a game, like in this abstract space, like you're talking about, with something that does follow a logical structure. I mean, I thought that was an interesting.
Yeah, but isn't that similar to what I was saying earlier? Because I remember if when I said that like you can create something not inherently illogical, but like that follows the rules.
That's what jumped into my brain when you said that, because it does sound that way. Like it's definitely something emergent. We've created something that doesn't behave like anything that we interact with. You know, it's just in a virtual space.
Yeah. Well, actually, okay. So I'll give you some food for thought. Okay. So. Let me get back to what I was saying before about like the postulates of geometry and like what would be weak emergence in that context. Like weak emergence is anything that inherently follows from that system. So like you could prove something to be true, like in basic math or basic arithmetic, you can prove that the square root of 2 is irrational. You can show it. Like, so anything that inherently follows from the system you've already built should be weakly emergent. It's strong emergence when there's no way to predict that thing from the system. Because have you heard that like within a strong mathematical system, there are true statements that you can't prove?
Yes.
Yeah, roughly, right? Like strong emergence, it seems to be that like new contexts, like new situations impose like new truths upon that system that you couldn't have predicted you couldn't have derived from the fundamental axioms. So that would be more similar to strong emergence, and that's what as far as I could tell, nobody has described strong emergence in that way, but it does seem to check out because it would follow that like there's no way to derive a strongly emergent truth, let's say, from the lower mathematical laws because it's something that's true, like that goes beyond the laws. So it's like kind of transcendental. So that would check out with the idea of strong emergence. But when I was discussing this on a different podcast, one thing that came up is like, are there more strongly emergent phenomena or more weakly emergent phenomena? And that was like a kind of puzzling question because you would think that like strong emergence is like the rarity, but like it's possible that strong emergence is just like so common and so so like inherently the nature of things that it's weak emergence that's really the one that we should focus on. But I say all of that because I gave the example. So I'll go back to my slides, the periodic table slides.
You know what? You know what's
Yeah.
jumping out right now?
What?
You actually made the example. So maybe a good example of weak emergence would be temperature, because you right, like you can see all of the parts and you know everything about them, and yet a new property emerges, meaning temperature, but it doesn't have any top down effect. Does it have a top down effect?
It might have a top down effect.
That guy keeps jumping in here. I like everything Chalmers was saying, like totally checked out in my brain. But when your dude was talking, like it was just not. It's not quite lining up.
Yeah.
And yeah.
Let's get. We can get back to consciousness in a second because we should discuss that because that in and of itself is an interesting and perplexing one. But right now, what I have on my screen is that periodic table of elements, and like these are all different. These are all different atoms. Now, what I think is that like let's just say I take like a random bunch of these atoms and just put them together. It's possible that itself will just inherently give me a strongly emergent phenomenon, and that has never existed in the universe before. Like me arranging these, like if I take like for example like 3 atoms of gold and then 1 of lead and then 1 of polonium and then like 2 of chlorine, something like that, and I just arrange them in some arbitrary way, that in and of itself might give me a strongly emergent phenomenon. So like
just to butt in quick, a buddy of mine who I went to school with, he recently invented exactly what you're talking about, like literally a new structure, a quantum filament actually, so it can be done, and it has like new properties. Yeah, so it's interesting.
That's cool. I'd like to know more about that. But I guess what I was trying to get at is like, there's like so many different ways to combine the different elements of the periodic table. So like, is it possible that there's just like a huge number of strongly emergent phenomena that will never exist in the universe because like the atoms just haven't been arranged that way? And like, this is all relevant to like the idea of possibility space. Like, what's the possibility space of the universe? Like, yeah, life is one thing that happened on this planet and it's led to all of this craziness. But like, given a different trajectory, is it possible that something completely different and something completely possible could have happened? It just didn't happen, and it won't ever happen, but it was still within that possibility space. Like, you see what I'm getting at?
Yeah, like, so are all of the strongly emergent characteristics like in some possibility space? And if so, like, does that possibility space have an end?
Yeah.
Because if it did, then it would almost seem like there's a limit to strongly emergent things, but that seems contradictory.
Yeah, but if there isn't a limit, that in and of itself seems like some craziness. Like, so one thing that could imply. So let's start talking about color and talking about consciousness. One thing that this could imply, and you can tell me your thoughts about this, is that there's literally an infinite number of colors. You can never run out of new colors. We can just keep evolving them and keep like creating new structures which generate new colors. And you wouldn't be able to exhaust all of the possible colors. And like that seems wrong to me. Like that doesn't seem like it makes inherent sense. And yet it seems to be implied by the existence of color. But like, what do you think about that?
Yeah, I agree. I think that it does seem as though there would be infinite colors.
You think that there would be infinite colors?
Yeah.
Because my brain literally breaks at thinking about that. Like, I can agree that there are probably more colors than I can perceive, and it could be a huge number of colors that I can't perceive. But there has to be a limit at some point, no?
Well, I mean, there's probably infinitely many universes with different starting subatomic particles. And yeah. I mean, we can talk. So we can talk about. I mean, the conversation about different types of infinity can, go on infinitely. But I mean, there's infinity in terms of like all of the things that we could possibly think about or interact with, in our universe. And then there's everything else. And I think that that's infinite too. So it's like, and we just can't conceive of it because, again, it just has different starting criteria. And I think that to think that like we live in the only coherent reality is silly. I don't think that, and like what's interesting about that question then is like, would logic be the same, like across all universes. You know,
That's an
and
interesting
like
question.
yeah, it is, and I think that I would probably argue yes, or else it wouldn't be logic. You know, like it.
I would say yes, but the only reason is because of multiple realizability. That it's possible to get the same structures using different arrangements. So like in a completely
Yeah,
different universe, they might not have atoms. They might not have like solids. Like they might not have matter in any sense that we understand, but they might be able to produce logic by figuring out a different way to arrange it. But you've gotten
if there's something like if there's something in a distinct and discrete place in space relative to other things, then logic should exist. You know, like
But does
in its
it? Yeah.
fundamental form.
Well, yeah. Well, I mean, we would probably debate about whether it exists or whether it has the potential to exist. I would say that it has the potential to exist, whereas I think that you would say that it does exist.
Well, yeah. All right, we're not. I guess we're not going to get over that verbal argument.
Okay. Okay. Let's start to move on towards consciousness and whether. So, okay, I want to give you another example of possibly of multiple realizability. So we'll talk about the color red. You look at any object that's red, and then the phenomenon of red appears in your brain. But I can show that it's possible to produce the phenomenon of red without all of that. So okay, so we can talk about like the physical process that gave rise to that phenomenon. You look at the object, and then photons of a particular wavelength hit your retina, and then this whole like cascade happens that goes to your brain and produces color. Okay.
Hey, I posted this picture.
This picture? Which picture?
I posted the one picture where you can trick your eyes into like seeing a color photo or whatever. Yeah, I know
Oh,
where you're
yeah,
going.
yeah, yeah.
I know where you're going with this. It's interesting. Keep going.
Yeah.
Sorry.
Yeah.
Didn't mean to-
So okay. So this is one conceivable way that the phenomenon of color could arise. Okay. And like you were talking about earlier, like, you know, if you like put a different input or if you reconstructed that, would that like just give you the phenomenon of red? Like, is the phenomenon of red somehow just this chemical physical cascade from your retina to your brain? And I would say like you can show that it can't be. Like it logically can't be, because if you close your eyes and imagine a red object, a red apple, a red, I don't know, unicorn, whatever the hell you want, you've produced the phenomenon of red in your mind, and yet most of the chemical cascade, which normally leads to you perceiving red, didn't occur. So you can't say that this cascade is equivalent to red. Red has to be something over and above this. It's the chemical cascade that's just facilitating it. But that means, so what this implies is that on a different planet, on a different, completely different planet with completely different conditions, they may have evolved, and like this evolution could have been completely tangential to what we even consider evolution, but they might be experiencing the same phenomenon, red, using a completely obscure and different mechanism to how we identify it. So this means that red it must be something over and above the matter which is giving rise to it.
Okay, I don't fully agree with that, but I do see what you're saying. The idea of like biomimicry and like even like creating a synthetic brain, and different, if we're mimicking different aspects of that cascade of electrical and chemical impulses, like you're talking about, like at what point do we get the red? Your visualization example is pretty good, but like I think that like if you know how parallel circuits work, I think that like your brain can self-stimulate, okay, like that same cascade that senses the red. Okay, so like you have like your mind's eye, and like so either your eye or your mind's eye can stimulate that red like perception. Okay, and like so. All right, like we can look at either the cascade all the way from the eye, like through the brain, and then producing the red, or we can look at the brain self-stimulating the red, and like it's probably stimulating the same part that the eye does, okay, but just from a different starting point. And I just think that I think that it is.
So
it could be mimicked, and you could produce. Now, whether or not it would be qualitatively the same, red, that I think that is literally impossible to tell. I don't
know if it's impossible to tell. It seems impossible.
Well, do we see the same? Do we see the same red?
I don't know.
Right?
I don't know.
Well, that's what I'm saying. How do we prove? You can't prove that. All we can say is that we have very similar processing systems and we consistently like agree that things are red.
Right. Like, I mean, I just don't want to ever shut off the possibility of ever understanding a mental phenomenon, because a mental phenomenon exists. We know that it exists. I mean, we've discussed this before, that like like as far as you can tell, your mental experience is the only thing that exists. So it definitely exists. And then the question we want to ask is, what is that? And I do believe it is something. It's not ethereal. But yeah, no, it seems at our current level, and even like conceptually, that it's difficult. It's difficult to make sense of that in terms of matter or any physical mechanism for that. You know, like this has been discussed a lot as like the hard problem of consciousness, that like it's inconceivable how any arrangement of matter, like no matter how complex it is, gives you any sort of experience. Now this is actually what Chalmers said. Like, so like I don't know if it was Chalmers who came up with the term strong emergence, but like he came up with it to like describe something like this, that like no matter what you do, like it's just inconceivable how you get from this step to the next step of there being red.
Yes. Yeah, and like even if you understand the system and like can reproduce it in different ways or the same way or whatever, like you'll just never fundamentally understand why that system creates red, or what the red is, like fundamentally speaking, that you're seeing. Like what the fuck is that? Like there is just I mean it's kind of like, it's just, again, in the possibility space, like the possibility of what we can actually know. Like we fundamentally cannot like interact with the world on a lower level than the subatomic, because of just our perspective and what type of being we are on what scale. Like we will never, if there is a way to predict like which slit the photon goes through in the double slit experiment, we are locked out of that information just based on the nature of our reality, right? So like, and so like, again, it like maybe the like how and what the red and where it comes from and why it exists at all, like is just in that unknowable realm. And like I've actually brought up before, and like this is totally relevant, but the idea of like the philosophical zombie, right? So something that like can perceive, and well, okay, using that word loosely, but perceive the color red and like react in like an effective and predictable way to that sensory input, but has no qualia, like has no conscious experience. And like how we would even know that, that again is even a good question. But like the idea of that, like, is that possible? Like, what does that mean? Like, could we? And again, maybe with AI, like with AI like becoming real, like now it is the question of like, okay, is this a philosophical zombie? Because it does see red, it does understand it in some way, shape, or form that's predictable and useful. Like does it have some type of conscious experience? You know,
I had a thought about that. This is something that I thought about a long time ago. I actually had a thought about this where like I think I realized that a computer only understands the color blue, or color. I used blue as the example when I was writing about this, but it only seems to understand the color blue after it's been shown an example. So like,
well, yeah. So in like this is the problem with AI. Like the problem with AI and the way that we have it configured right now, and is that we are the sense makers. We are the sensors. Okay, like we can feed it pictures, but we take the pictures. Like we decide like what's relevant to look at, and like and how to interpret it. And then like especially in the case of large language models, it's just a giant neural network of words that have definitions that are loosely connected to one another, and then it travels down this path of like which words are associated with which words, that we give the meaning to based on the context of our actual sense making experience, and so like in that sense, like the AIs are a philosophical zombie, and that they really aren't seeing red. Like we see red and we describe it and we categorize it, and then the AI does computation on it, so it's kind of creepy, and like and what's even creepier is to then think, okay, well, how do we make an AI that that we don't need to sense make for, and that's AGI, and so like and there, what that could look like, again, like the reproducibility, it could maybe take many forms. I mean, there's no reason to think that it couldn't. I mean, like conscious life forms take many different forms too, and they're conscious. We have to assume that their consciousness is different, but at the same time, there seems to be that thread of consciousness in there somewhere,
Yeah, that it is very, I mean, like people have puzzled over this, and like especially because it's becoming our reality now. So So like you can get a neural network. Like I guess it's very probably straightforward now to like be able to identify colors, right? Like it has some kind of like eye that can perceive different objects, and then it can tell you what color the object is. That's definitely a thing, right?
Yeah, but like you're saying, we like the sensor, the camera, like it has a bunch of sensors in it. But
Yeah.
unless we like we say, oh, that's red, that's green, that's blue, and then actually within the structure of the camera and the way that it's fed into the computer, then
Right.
the AI is not generally intelligent, so it can't just take all this random data like a baby would and start to like to see patterns within it like spontaneously. Like
Right.
we have to give it the starting point to some extent.
So it's just
And that,
it's just like referencing what it has, what we've given it in its memory. It's like comparing. It's like, okay, this object corresponds to this thing that's in my structure, and then that's going to be my output. So it's not like it's basically just referencing what's internally within it.
yes, yes. Yeah, and like something that's interesting too is like the idea of, okay, we start at the same point. Okay, we feed the same image or prompt into an AI, and like even the same AI, and yet it seems like sometimes it produces different outputs. You know what I mean? And so maybe this is in a way that is different from a discrete computer, which was another gripe that I had, like with the example that he made, which was that like what you described was an AI, where it's a black box where we throw in an input and get an output, and we don't know what happened in between. But a traditional computer is not that way, in that it is discrete and we can follow every step. You know.
Yeah. Well, okay. So if I use color as an example again, and then relate it back to like this idea of transistors or logic being strongly emergent, what I mean, like, okay, yeah, you could say red in and of itself is not predictable or like understandable just by following physics or following the mechanics of physics. But once red comes into existence, regardless of where it came from or what it is, if you want to predict, so like obviously the color red leads to a slightly different universe. So first of all, okay, well, I'll ask this question and then you can answer it later, is whether you think color inherently exists in the universe or whether it only started to exist when beings with eyes started to evolve. Did color exist before that?
It's a really great question, and no, it didn't exist.
Okay,
It
interesting.
didn't. Yeah, no, it did not exist. And like, and even what's interesting is that people who are colorblind, for instance, will say that something is a color that everyone else agrees is not. Like
Right.
just because of the way that their optical system is set up.
Yeah.
Like so. I mean, red existed in the universe before we existed in terms of like, okay, we arbitrarily have decided that this wavelength of light is red, and that has always,
Wait,
it's not like that.
wavelengths. Wavelengths have always existed, but like this.
Yes.
Right.
Yeah, and the wavelength that we interpret as red has always existed, but the actual concept and the experience of red did
Yeah.
not exist
Well, because
until
it's interchangeable. Like it's completely arbitrary that this wavelength gives us that perception, because you could just completely rewire your brain such that that wavelength gives you the color blue. It's just a way of coding what we see in the
I
world.
wonder if anyone's ever done that.
Yeah,
I wonder.
that'd be interesting.
You know what I mean?
You would have to get really good at operating at the cellular level on like the tiniest neurons. But yeah, that would be.
I wonder if anyone's had a genetic mutation where they've had like a rewire like that, where they have a color
Well,
inversion.
how would you tell?
How would they know? How would they know? How would
Exactly.
you ever know?
They would go their entire lives thinking that everybody perceived color the exact same way that they did. They were perceiving the exact opposite color. Yeah, I thought about that as well. Like that person would never know. But people who are colorblind can know because like you can do tests.
Because there's discrepancies. There's discrepancies.
Yeah, and like
I wonder if they've ever done tests and found people that are cross-wired or whatever.
Yeah.
Where,
Well,
like,
they have found people that can see more colors.
Yes. Yeah, that's
Tetrachromats.
true.
I don't know
So
if Sorry, yeah.
do they have extra cones then? Do
Yeah,
they have
they
extra
have.
cones?
Yeah, they have one extra cone. They have an extra cone. Hold on. How does it work? I'm not sure how it works in humans, because when I'm thinking about it, I'm thinking about birds, and the reason birds can see more colors is because that cone can detect UV. But like it would seem, I don't know if people can detect UV or just like I think it's the one that detects blue can detect slightly higher frequencies, and they have that.
So in like a low light condition where there happens to be UV, they'll see it as blue. kind of is what you're saying.
Yeah,
Is that what you're saying?
they perceive it in some way. I don't know if they see it as blue. No, but no. What I'm saying more specifically is that like they have their blue color cone. It's like mutated slightly such that it gets stimulated with higher frequencies.
Gotcha.
And I
Okay.
don't know. I don't know if that we know that they can see more colors, but I'm not sure how that specifically would cause them to see more colors. It does kind of. I mean, now thinking about it, it does kind of point to the possibility that there is some connection between wavelengths and light and color. Yeah, as far as you and I both know, like there's no inherent connection. But so let me take a step back. The color red.
We're getting in the weeds here.
Yeah. So the color red is significant in that once we started to see red, the universe started to play out differently. So we
Yeah. So just to interject, like, so I had this poison ivy example, and it's interesting in a couple different contexts, but like now this is like more of a rod thing. So like just being able to perceive the shape of something, but like the second that we were able to perceive the shape and correlate getting an itchy rash with poison ivy, then we created a word for it and started communicating it with other people, and then we avoid it, like you're saying, and so it becomes a top-down effect. And so like you're saying, like, okay, we see red, and then okay, now we're gonna avoid fire, which isn't a great example,
Right.
but things like that, you know, like
well,
red,
the
red
example
means danger. Yeah.
the example I would bring up is like we could see fruits, or like we could see ripe fruits better, so that attracts us to them, and that's actually probably the reason why primates can see red, is that to differentiate between
and probably predators and like poisonous insects and,
Right.
and frogs and shit.
I mean, yeah, those are good examples. Like anything that's like brightly red is probably a danger sign. But like, yeah, so like once the color red comes into existence, the universe's trajectory is now altered. Things will not play out the same way because now we're going to be avoiding certain animals and we're going to be attracted to certain things or fruits that are brightly red as far as we can perceive them. Now, in the context of what we were discussing earlier, like this system, let's say this system of the universe that's in this new state is fully predictable. It's fully deterministic. So it's not like chaotic and random. It's not unpredictable, but you need to add red to your picture of the universe in order to fully account for it. So like regardless of where red came from or what kind of phenomenon red is, the universe still makes sense if you just add red into the picture. So I don't know where it came from, but assuming it exists, if I throw it in there, like, does the universe make sense? And it still does. It's still consistent. So it seems that like strong emergence might be these phenomena, which again, like just they kind of their existence is hard to pinpoint, but once they exist, we can still make predictions if we add them to this new picture of the universe. And it's the same thing with the transistors, and that's the argument he makes with the transistors, is that like this thing that we've done, that we've created using these crystals, using silicon and doping it in certain ways, this thing that we've created never existed before. And there's no way to have predicted its existence from the bottom level. But now that it does exist, like the universe is still consistent. It's just that we need to throw in this extra bit of knowledge in order to fully understand our or in order to get the predictions to be correct. Whereas just the bottom level will give you incorrect predictions. And so red, like as an like this is why I wanted to like introduce the term super strongly emergent to be an emergent phenomenon that doesn't even make sense at the physical level. Like, I mean,
like the qualia of red.
Yeah, qualia, exactly, the experience of red, and any kind of mental experience for that matter, as being like in a new category. But I mean, it's possible. I mean, like I don't know if you've ever heard of like the theory that like I mean, I'm not gonna like posit this as what I believe, but like that like we're tapping into consciousness. Like that our brains are like a radio receiver and we like tune into it. So if that's the case, it means that like experience or consciousness kind of does inherently exist, and then we tune into it, and then that's when it kind of becomes realized in the universe. And so if you think about this, and I don't want to like dwell on this for too long, but if you think about this, all this is saying is that the universe prior, so the possibility of the color red, or not the possibility, the color red does exist in some inherent sense, like in the universe, but our ability to perceive the color red, like it kind of like, let's say, entangles the universe, between this higher phenomenon and the physical universe, such that they're now like interrelated. What I'm trying to get at is that like you could conceivably understand color in some sense that has nothing to do with physics, and then that would consist of your understanding of the color red. And then somehow when this phenomenon can tap into our universe, like that's when it becomes correlated with the physical world. And so all you need to do to understand the complete picture is to throw this new phenomenon into your picture, and then it makes perfect sense. But yeah, there's probably a lot there for you to digest. I don't know which thread you want to entangle.
Okay. All right. So I think that now the red example is helpful, but also it gets less helpful because it's like it's a pretty base level physical phenomena. Okay. Now, if we talk about another qualia like love or pain or really any psychological phenomena, then that doesn't that isn't just a wavelength. Okay, that is like a qualitative experience, and then like you're saying, like we have to take this concept and throw it into the picture and then that will change our predictions.
Yeah.
That might be better just because like it isn't as reducible like to the wavelength thing. And that's just like where my brain is going. It might be like a stronger example, but
I mean the wavelength thing is just the physical picture that that physicists have convinced us is true and which constitutes red. Like, oh, we understand red because we can see how this wavelength causes this chemical reaction inside your brain. But like you and I both know, we haven't really explained red. We've just correlated the experience of red with this physical process. And what strong emergence tells us is that you can get a completely different physical process to give you the same phenomenon. The same way you can get a water circuit to work. A completely different setup will give you the same thing. So like the physics picture is like it tells us how it's realized, how the phenomenon is realized in our case. It doesn't tell us whether or not this phenomenon can be realized in other ways, and I would say that it can, because remember I gave you the example of like producing color in your brain, and then you responded by saying like, well, apart from like the input to your eyes, it could be your brain just kind of stimulating the circuits that produce the phenomenon of red, anyways. So it's like your brain producing it using the same circuitry. It's just missing some inputs. Now that's possibly the case. I'm not like super familiar with it, but I do believe there's a distinction between when you close your eyes and use your mind's eye to perceive the color red and the experience of the color red. They don't exactly take place in the same parts of the brain, to put it simply.
Okay.
And I think that would show
that's really interesting.
Yeah.
That's super interesting.
What has to do with like imagination and like the way imagination like it's complicated. Yeah. But it does. So but I would even argue that even if it was just kind of like your brain activating those exact same pathways which lead to the phenomenon of red, it's still realized in a different way. Like it's still the phenomenon occurring, like not by different means. Like because like it's like when you perceive the color red.
It probably is a strongly emergent way, because I don't think that I mean it's kind of speculative, but probably not all beings have a mind's eye. I mean, and even some humans have aphantasia, so they don't have one. So, I mean,
can I tell you something quickly? I met a person who had aphantasia once, and I didn't know that he had aphantasia. And this was in a class where we were practicing like mindfulness techniques as part of my like psychotherapy lectures. And I asked him to do a visual meditation using his imagination, and he went through the whole thing like for 5 minutes, and then afterwards he tells me, "Yeah, I don't have a mind's eye."
So I mean, did you ask, like, what was he doing?
He literally just sat there in silence, listening to me tell him to visualize these things, and nothing was occurring inside his head. I don't know why he didn't just interrupt and say. Anyways, that was fun. But yeah, go on. You were saying
it's kind of amazing. I mean, it does seem like it's a very like critical like ability to have as a human, and yet we like some people don't have it. And have you heard of the one where some people don't have an internal monologue too?
That one's very eerie to me and very strange. I don't know. I can't. It's hard. It's so hard. I don't get how it's possible to speak without being able to produce language inside your head. But
Yeah, it
apparently,
is. Yeah, well, it's like it's like Mary in the room. Like we can't imagine what it's like to have a different qualitative experience, kind of. You know. Um.
that is their reality.
Yeah. I've heard. Yeah. So as far as that one goes, I heard of like a case where a person had like a stroke or something, and they were actually able to like recount what it was like to lose their internal monologue, and like what it
Oh.
like having known what it was like to have one. And I've heard that people who don't have an internal monologue actually deal with stress and trauma a little bit better, and because they don't like ruminate on things as much.
Makes sense.
Um, yeah,
I would love to go like even 5 minutes without my internal monologue. That motherfucker does not shut up.
yeah, we're both ADD, so I get what you mean.
Yeah.
Yeah, I definitely share that sentiment.
Yeah. Where were we going with this? I mean, okay, hold on. So actually, I just had a thought. Like, language. Okay, so we can see how language would be strongly emergent in multiple senses. Like for example, like just think of like so the building block. So okay, hold on. There's so much to talk about when it comes to language, and like what kind of a thing is language. I have this slide up, and like whether it's meaningful, because some physicists would say that like, okay, a phenomenon like language, sure, like it's complicated, but it's not fundamentally different from physics. Like the reason we have to come up with like a theory of linguistics is to simplify what is otherwise very complicated physics. And of course, there is very complicated physics happening in any phenomenon which involves humans doing things, but there's something over and above that, such that the physical picture literally tells you nothing. All the physics does is facilitate this kind of possibility of language, and then language starts to follow rules that are completely tangential to the physical world and don't even make sense. Like it makes no sense whatsoever to describe language and linguistics in terms of physics, even though a lot of people are convinced that you can. Because there are phenomena which happen within languages, the way languages mutate. The fact that, like, for example, language exists in a kind of collective neural network of every human that agrees that those words correspond to those meanings. Like, that's where language is. But then you also have things like writing and what kind of a thing writing is. And like when you look at these scribbles on a page, the fact that it produces meaning in your head. And like I can show you one thing about like emergence in general that has to do with written language. It's like, because again, writing and written words are composed of letters. Okay, so you can think of like letters as being more fundamental than words themselves, but like there's no sense in which all you have to do is add up the letters and then you can figure out what the word is, right? Like the meaning contained therein is over and beyond the subunits. The subunits just kind of facilitate the thing existing. And then it goes on living on like another dimension relative to those subunits. But you see what I mean?
Like a sentence has like an emergent meaning, like beyond the constituent parts of its words.
Yeah, and it's like it's the arrangement. It's the arrangement of the words in the sentence. And like there's no sense in which you just add up each individual letter to give you the meaning of the sentence. Like the whole thing together is the new phenomenon. And because it doesn't follow logically just from putting the parts together, it must. I mean, depending on how we define strong emergence, it would seem to be strongly emergent in that sense, because again, there's no sense in which adding up the subunits will give you what's happening at the higher level. Like the higher level exists when the subunits interact in a very specific way, rather than just being summed up. So let's say a sentence is more than the sum of its parts.
Yes. Yeah, I agree with that. I struggle with the idea that, and it sounds silly coming out of your mouth, but like the idea that it does feel like maybe language is actually reducible to physics, just in the sense that, I mean, language does refer to things, like it references the world, which is physical.
Right, but what is referencing? Isn't referencing a new phenomenon?
Yeah, probably.
Yeah.
But yeah. So maybe aspects of language are emergent.
Sure. Like the thing is, the physics picture is not irrelevant. It's relevant. Like, for example, like when you and I are in the same room and I talk, there are sound waves being exchanged, right? Like there's mechanisms occurring through sound moving through air, which you can explain at a physical level. So like it's not irrelevant. Physics is facilitating all of this. But then what I'm saying is that language itself starts to occupy this higher domain, and you can talk about language within this domain, and it has nothing to do with physics per se. The physics, because you can have completely different physics, and yet this thing at the top domain is still is still true. Let's say. So like
okay,
yeah,
like how you program non-Euclidean geometry in a video game.
yeah,
Or something.
yeah, something like that. And like, do you see how like I really want to hammer home that point of like this new phenomenon has to exist on a different plane relative to physics, because like a lot of the things you talk about in linguistics are just so abstract, and they have nothing to like. Again, like physics can be thrown into the picture, but like the question is, why would you throw it into the picture? There's so much that you can talk about in linguistics that has nothing to do with physics whatsoever. Like the phenomenon of like words slowly dropping from the vocabulary of people, or like the phenomenon of different people in different places developing different accents. Like a lot of that is like, it doesn't really have anything to do with physics. And even if it does, the physics picture isn't really giving you information about what's happening at the higher level. I want to quickly go to a different example. Yeah, go ahead.
I like the accent one. I like that feels like the crapshoot example, and that like okay, you start with the same starting scenario, and yet you can't predict like where it's going to end up. Like accents seem like just totally unpredictable and random like that. You know? Maybe it has something to do with geography, but probably not much. You know.
Well, I would even say okay. Let's say that geography is relevant. Geography is a global picture. It's a global phenomenon. It's not like individual particles don't comprise your geography. Your geography is like a collection of these particles at a higher level. So even if geography is related to your accent, like geography is itself a higher level phenomenon, which is having a downward causal effect upon your accent. Obviously, I don't know if I don't think either of us thinks that that's actually the case, or that's actually how accents develop. But like, if that were the case, this would also be strongly emergent. That effect of geography upon your accent is a top-down effect, because it's something at a higher level influencing something at a lower level. Like a better example would be like the relationship. Hold on, let me pull it up on the slides just for people to see. The relationship between, God, where is it? Aristotle. Nope. Okay, there. So it's the relationship between the society, yourself, and your genes. Okay. So your society shapes you, obviously, right? Like the language you speak is a consequence of the society you were born into, and yet this society requires you as to be a constituent of it. Okay. So you are a member of this thing called the society. And everybody who's also a part of it is like one of the constituents of this thing. And together, that collective system influences you at a lower level. So even though you're part of this system, so like think about again like quarks in an atom. Like even though the quarks are part of the atom, the thing at the higher level, society, is changing those quarks. So the language you speak is a consequence of your society, even though you are within society. Do you see how that's like a top-down effect, which can easily be applied to something like an atom?
Yeah, the atom is based on the interactions within it. It is holding the quarks in a specific position and like affecting how they're moving and acting.
Yeah, But
the quarks also play a bottom up role in that they're necessary for the function and structure of the atom itself. And just
exactly.
Yeah.
Exactly. And we can what I've shown in this slide is that's the same thing as emergence, like emergence in general. When the bottom level facilitates the existence of the higher level,
but the higher level affects the bottom level.
Yeah, that would be strong emergence. But in the case of like a society, because this is a really like simple example, like obviously society affects you, but then you can affect society. Okay, for an example, if you decide to speak English with a different accent, like you just decide, like I'm going to speak English with a different accent.
Or you just start making up new words.
Sure, yeah, that's actually a much better example. But if you start just throwing new words into the vocabulary, people in your society might start to adopt that. And like society itself will start to change as a consequence of you affecting society. So society is affecting you from this top-down way, but then you can affect society in this upwards way, and they're kind of like linked to each other in this chain of causation, where you can't account for the one direction without thinking about the other direction. And then in this slide, yeah, go ahead.
I think that one of the, then the question, the weak emergence thing is really digging at me. I think that the temperature one might be the closest and best example I've thought that we've thought of for weak emergence. But I'm struggling to find other ones then at that point.
Something like, oh, remember we talked about Ohm's law? I mean, nobody's even shown that Ohm's law is weakly emergent, and it seems to be strongly emergent as well. Dusty, the thing is, like, if most of the phenomena we're talking about are strongly emergent, it doesn't surprise me that much, because this is all from a level of fundamental physics, which is so complicated. And not only that, it involves stochastic processes. It involves quantum mechanics, which is random. So you have a system of math that has randomness built into it. We shouldn't be that surprised that the universe is capable of producing a shit ton of strongly emergent phenomena. Because, like, remember the example of the game of life I was telling you about. It's so simple, and yet within this very simple system,
when it has randomness introduced, it becomes emergent.
Well, do you mean the game of life or like the universe?
Yeah. Well, both. It's that unpredictability factor that produces like these emergent properties.
That's an interesting discussion because with the game of life, it's not really about there's nothing random happening. It's fully deterministic. It's just this top down effect is making your bottom up attempts to predict it wrong. You're getting the wrong answers because of this top down effect. But the randomness
But isn't the top down effect random?
The top down effect isn't random. It's well, what do you mean by random? Like, what does anyone mean by random?
Unpredictable, right? I mean, just. That's what random is, right? I mean, unpredictable.
Well, okay, yeah. No, okay. In that sense, yes, any strongly emergent phenomenon is unpredictable because there's no way you could show. Well, no, maybe. Oh God, damn it. Yeah, we should. Okay.
You see what you just did there?
Yeah. No, I see. Yeah, I mean, I think I did read one paper. Let me see what it was called. I don't have it in my. It was one of the ones about game of life. And the title of it is Strong Emergence Arising from Weak Emergence. And one of the things they say in it is that, like, these distinctions maybe aren't as
important.
Well, not unimportant. They're just like not as firm as we've supposed them to be.
Well, I mean, we've been talking about that, where it seems like it's almost on a gradient sometimes, where it's like in this gray area where it's hard to figure out. I mean,
the thing is, okay, if I think about the game of life example, like I would say, like, you can predict the existence of a strongly emergent structure from the lower level, but once that structure exists, like once it comes into being, the effect it has on the overall system of which it's a part is no longer predictable from the lower level. So like it's like as if it's like weak emergence.
But it is predictable from the higher level once you understand the
from both levels
which direct it.
Yeah. Once you understand what that effect is, you're good to go in terms of your predictions. So the picture that I'm trying to conjure in my mind is like, imagine like you have the game of life and it's like generating new cells, and like it's slowly building to like a very complicated arrangement of cells. And like you can keep like iterating the process and using your predictions to see what's going to happen. And then at kind of like a threshold point, you get to this phenomenon, and you could have predicted that phenomenon beforehand, but now your predictions are completely going to be off.
Okay.
So like,
yeah, you hit that critical mass, and now you have like in some sense an unpredictable agent.
Yeah.
Like okay.
Well, it was predictable beforehand, but now it's like now where it goes is unpredictable without looking at this new thing as like a genuine entity, as like a real
how it's arranged itself.
Well, I think more like what its effect is, because how it's arranged itself could probably tell you about the effect. It's the effect you want to know about.
Because of the reproducibility thing, because multiple things can create the same effect.
Yeah, exactly. Yeah, and I think that's even been shown that like you can get a completely different kind of structure in the game of life, but then it causes the same downwards effect, which is. That in and of itself is just so eerie that you can get this to happen in a computer simulation that's like just utterly simple. Like it should really mean that like there's nothing crazy about strong emergence. It's like the norm. We've made it crazy because of physicalism and because of reductionism. Like because we've assumed these things to be the truth about our universe. Now strong emergence seems like this crazy thing, but in reality, it makes perfect sense.
Yeah, and I mean, my Achilles heel, argument, and just I always try to bring things back to, it's like, I mean, fundamentally, everything is strongly emergent from nothing. Like there is nothing that is not emergent in some sense.
Yeah, I
And
mean,
just
I was thinking about that because like yeah, I like the way I always framed it was like fundamental physics is your lowest level, but then you told me like what about nothing, and that was very very interesting because because
it's kind of it's the ace in the hole. It's like it's the one thing that you can think about in almost any philosophical context, and it just opens up so many more questions, and it is relevant in this scenario because, I mean, obviously, space and existence in general is a new attribute from nothingness, so it's just like, so it kind of ties into what you're saying. It's like we think like, oh, things are predictable and reproducible, and we live in a dominoes type materialistic world, and then but maybe there's this weird thing called strong emergence. It's like it's kind of like Neo in the Matrix, not being able to see outside or where he is within everything else. It's like, yeah.
let me throw this question at you. Do you think would you think, or would you be inclined to think that bottom-up emergence or bottom-up effects are more fundamental than top-down?
Yes, sure.
Right.
Yeah.
Because I think it's definitely possible that you can have nothing at the lowest level and then something higher at the highest level, and then these two things co-create reality. Because there's no inherent reason to think that bottom up there's actually very good reason, never mind, there's very good reason to think that bottom up causation is more fundamental than top down. But if you think about like in a global metaphysics picture, there's no inherent reason why top down should be, or bottom up should be more fundamental than top down. In fact, like if you're religious, like existence is top down. It started as top down. You had the very highest possible being, God, creating reality. So reality itself is firstly a top down effect, and then all this bottom up stuff is just what happens in the universe. But like that's why it's conceivable that top down and bottom up, or that top down and bottom up could be both fundamental.
Well, I mean, fundamental is it's fundamental to the shape and continuation of reality. But as far as like fundamental in the sense of like firstness or like primariness, I think that emergence and the concept of top down, like in general, it requires more basic starting blocks, right. That's the nature of it, is that it was built from smaller things,
right? But so that every particle is like is an excitation in a quantum field, and then a global quantum field, right? Like, well, let me explain this a little better for the 7 people who are watching. Like, the idea is that like you have these particles, but each particle is just a little bit of energy in a field. So you have a field which encompasses the entire universe, and then anywhere you see particles is just where the field has energy. So wouldn't you say that like a quantum field itself is a global phenomenon? And by being a global phenomenon, we would have to have a top-down effect upon the smaller things.
Yes, but I mean, where did that come from? Like, where did that energy come from? Where did the space in which the energy is placed come from? Like, it.
I mean,
so have I done the annihilation argument with you? Have we talked about this?
I'm not sure.
Specifically?
If you could go through it again.
The bottle thing, where it's the question of like, when is the bottle empty? And
this might have come up, but it's not ringing a bell.
Okay, well, it's literally just the idea of like what does it mean for something to be anything? Okay, what does it mean for a bottle to be empty? Like we have this scientific understanding from a physics perspective of like of space being empty nothingness. Like it is nothing.
Yeah.
Okay, but like the thing and so the three different possibilities are okay. The bottle has there's empty space in it, and that empty space constitutes nothingness. I think there's two relevant possibilities. Then the other one is that the walls of the bottle are the only way that there can be nothing in it is for the walls of the bottle to be touching, which kind of seems like it's meaningless then at that point.
Right.
But like, so the whole point of the class was it was actually Spinozan in the and he was talking about how we basically attribute we give different attributes to extended objects, and like the punchline of the whole thought experiment is
Nothing
just
exists.
that well no that space itself is something, and the reason why it's something is because it takes time for something to pass through it. Okay, whereas like if there truly nothingness would not have any attribute. Okay, does that make sense?
Yeah, that makes sense.
So like space has an attribute, and so like even the existence of the space is like secondary to nothingness itself.
Right.
Okay, so like and from that perspective, like literally every single thing it would be strongly emergent because it comes I mean it's not even emergent then at that point because it's constituted of parts which are nothing, so it's like it's something else. But I think that it definitely like gives credence to the idea of emergent properties. I mean, like in general, it's just like what different types are they, and like is strong versus weak even a real distinction? And then like what is it? I mean, this has been a really good conversation though. I feel like we're at least like doing something productive and talking about this.
Yeah. I take it that means you got to go soon.
No, I don't. No, I mean we could do another half hour at least.
Okay, yeah, I'm good for another half hour. I mean, if we have stuff to talk about, I mean, we might add.
Yeah. Let's see how it goes.
Yeah. So let me tackle a thread. So I had some thoughts. I don't know if like this is even worth discussing.
Yeah, I want to hear them because I mean, like now we've kind of like really driven it all the way down to like
literally nothing.
The real nitty gritty, you know, which we if we stay here too long, we probably won't get anywhere.
I mean, I don't know if you've seen my videos about Heidegger and like the nothing and like how in a metaphysics
I have,
sense,
yeah.
Okay, great.
I
Yeah.
have.
Yeah, because like one of the conclusions is that from that is that like nothing is so fundamental that like the existence of everything is completely contingent on the existence of nothing. Like without nothing, there would not be something. Like nothing is like a critical component for there to be anything, which is such a weird I don't even know conclusion to come to.
Well, I agree. When
It makes sense.
It makes sense. I mean, just like it's the primary secondary thing that I talk about. Like,
Yeah.
It's like we want to think like we as humans think about things temporally. So we want to say before there was anything, there was nothing. But like even that gets sketchy because time is really just space, and like even space didn't exist. So it's like you gotta like it gets wild. But I mean, I think that like the world it just continues to emerge, you know, and like and we probably can have infinitely many types of conscious experiences. I think it's important to like try to figure out like under which scenarios that occurs, because I think that that's like it's like if a tree falls in the woods, like does it make a noise? Like I don't think that we should care much about like the problems of philosophical zombies, you know, like if an AI like has a beef with another AI, it's like if it has no conscious experience, then I don't think that that's like something we should be paying attention to or like be worried about unless it's going to affect something with a conscious experience. You know, so like talking about all this stuff and then and like really considering, you know, even from an engineering perspective, it's like, okay, we're going to do the biomimicry of creating an AGI. Like, is that going to be conscious? Like, what is that consciousness going to like look like? And yeah, like because of strong emergence in general, like we can't have 100% predictive power, but like it does seem like, again, it's on this gradient where it's like, okay, we have a pretty good idea that something about this process with the rods and the cones like produces the color red in your qualitative experience. And so when we create a machine that does something like this, we better be careful, you know, like just even from an ethical perspective. And you know, it's like, and also being really, really careful about like being not being negligent, like when we create new emergent properties, like my buddy creating the quantum filament, or the atomic bomb, or PFAS, or any of these things. It's like
What's a
we
PFA?
can't Teflon, like the forever chemicals.
Oh, right.
Yeah. So like we create things that haven't existed before, and like if we don't pay attention to their new emergent properties, then just from a very practical perspective, it's going to be bad for us.
Yeah, you get shit like Chernobyl happening.
Yeah.
Something that's literally never happened in the universe.
Yeah, I mean that we know of. At least definitely not the way it happened here.
Yeah.
Like I'm sure it was at least to some extent unique.
Yeah.
Uniquely human.
Well, unique because it involved consciousness of our knowledge of particle physics and like how if you get a certain concentration of this element, you can get this property out of it. So like, there's no way to have predicted that occurring without putting consciousness into your picture. So like it's strongly emergent in that sense. But then like you don't know what the limits are, like where, like what kinds of different emergent and different phenomena can start to exist in the universe. This
is a good question. So like, is there? And I think that this has been discussed significantly. But like, is the idea of a philosophical zombie even possible? Like, could you create something which, you know what I mean? Like, I don't know. Like,
I've heard people say that like if you create a philosophical zombie, like okay, a pure physicalist would be like if you create a philosophical zombie, you've created consciousness. Because if you created a being that in every way is material, is like composed of the same matter as a human, but for some reason doesn't experience, a physicalist would just say no. They like it's impossible for them to not be experiencing something because that arrangement of matter will just give you experience. Like it's not possible for them to not be having an experience. And like whether like a human philosophical zombie is possible, like my intuition says like no, because I kind of agree that like if you do have that arrangement, you will get experience, but not because that arrangement is equivalent to experience. It's just because somehow experience has emerged in that system. I don't understand how it emerged, but like it's really hard for me to conceive of an entire human at the material level not experiencing something. I mean, like, okay, like if I look at any object in my room, I'm pretty confident that this mug in front of me is not experiencing anything. I don't know, but like I have no reason to think that it is. But when it comes to like artificial intelligence, it starts to do things that give you the impression that it might be experiencing. Like I brought up this example one time at during a meeting of like there was an AI that was programmed to play Tetris. And it was programmed like to not lose, but then eventually the game became so impossible that it was inevitable that it was going to lose. And at the instant before it lost, it paused the game.
Yeah. It won.
Well, it didn't lose. It avoided losing.
Yeah.
Which it was programmed to do. But like on the one hand, that seems completely like it seems like a novel behavior. And I would say that
did you hear about the AI playing Go? Did you hear about this?
Oh yeah. Like it played some really random move that puzzled the people.
And it changed the whole game. Like it literally like changed the whole way that people like strategized and thought about Go.
That's really interesting. Jeez, yeah. That's mind blowing.
Yeah, and so like I guess there's different conceptions of like what the philosophical zombie would be. I mean, I'm tempted to agree that like anything with the same physical form, like down to the nitty gritty, like would have to have like a conscious experience. But I guess the idea would be like, could it like navigate the world in every way that would be relevant, but in such a different way? And
I believe pure physics can never account for the complexity of human behavior. We are something else. We're not a bunch of atoms, because I can take like the atoms in your body, the atoms. Okay, so we've had this conversation and neurons have been firing in both of our brains nonstop. And like a bunch of atoms have been shed from the system, and yet the system continues because the atoms are interchangeable. The specific matter is irrelevant. The matter is just facilitating it. Let's say the phenomenon of being a human is not reducible to matter. It's something new it's a completely different type of phenomenon. Like a human is not just a bunch of particles moving in a certain way. So I'm not convinced that like a being could mimic human behavior without
being human.
without being human. Yeah. But the question I guess we want to ask is like, so let's do a thought experiment. So I think this is approaching a possible solution to whether. I mean, it doesn't answer the question, but it does kind of like pose an ethical challenge. It's like imagine that I gave an AI autonomy. So I programmed a robot, and like it was just like a normal robot, like one of those Boston Dynamics robots. But I gave it like the ability to I programmed autonomy into it. Like maybe it has like some certain programs like survive at all costs or something like that I gave it beforehand. But like now with the system running, it now kind of behaves autonomously. And would you say, because a part of me feels like, so I remember when I was a kid, and like, one of the reasons I'm really fascinated with animals is because of this one experience where I was at like a zoo, and my parents told me to look into a telescope, like not a telescope, but one of those like small telescopes that you can use to see animals. And I looked into it, and I saw a bunch of deer moving. And like in that moment, I had this realization of that, like, wait a second, they're moving by themselves. Like nothing's pushing them. Like they're autonomous. And I think that's when I had the sense of like them being a living conscious being, is like they were able to just like move on their own. So if you program autonomy into a being and it starts to behave autonomously, and like you add other things, so like the ability to like perceive its environment and then distinguish colors and distinguish objects, and I load all of that into its memory, the ability to navigate its environment, would you say that this would, I mean, I don't even know what question to pose, but like, would this start to be approaching some kind of experience, like if it's capable of acting autonomously?
It would totally depend on how it was, like in the interrelated structure of how it was interacting. I don't know. I mean, I think that, I mean, what you're describing is like a form of AGI, okay? But like not the biomimicry version.
Would you say AGI is the same thing as a conscious being, or is it just intelligence that can do anything? Because, well, I mean, yeah.
Well, so that's what I'm trying to drive at. So like you can, in theory, you could create a zombie version, or you could create a living version if you want to use that terminology. But they would be very different machines, you know. So like what you're describing is basically like, oh yeah, you give it these preconceived notions, like survival, and even what's funny is that like a preconceived notion for humans is red, like it is literally like the instinctual like structure of our brain, and like our ability to process red. Like we could make this being like see different colors, but we would probably want it to see colors that we see, because that would be most useful to us. But like I think that it would totally depend on how like it was actually doing the processing. Okay, right. Like if it was just an LLM, hooked up to a Boston Dynamics robot, then I think that's like at least a lot closer to a philosophical zombie than something that would be like we've been talking about, like on the Discord server, where we're trying to like replicate and biomimic an actual like a gigantic cluster of neurons, and then give them some basic structure like how our brain has basic instinctual structure, and then like create regulator basically like voltage injectors that would like modulate the frequency of these synthetic neurons such that it would mimic the way that the human brain works. And I don't think that it would produce a one-to-one experience, but I think it would be very close, but that would not be the same as, like I said, like hooking a Boston Dynamics robot up and then having some type of fancy AGI overlay on an LLM and then telling it to go be autonomous. Like it would not have a conscious experience. And I think that this ties into what you're saying, in that like that our conscious experience and our language and our feelings and our concepts like exist in a plane and in a relevance of their own. And so like even though, and here's an interesting question, like if they were in some sense like equivalent, or were engineered to be equivalent, but they were built different ways, like if they had like different parts, like would they diverge, and like based on like the idea that one has a conscious experience and one doesn't? I don't know. I don't know. I really liked your I really liked how you like your last free will video. That was I didn't finish it on my second listen through. I was trying to prep for this. But I that was pretty persuasive to me. Like just the idea that like from the complexity of like self-awareness, like we have free will. And like maybe both of those machines that I described like could even have that cat. I think we even like touched on this. Like, could something that has no conscious experience still have free will, right? So we even talked about that a little bit.
Yeah. I mean, but do you know what my answer to that would be though? Given what I know now about strong emergence or about emergence in general, is that it would seem like yes. The answer would actually be yes. It's possible for a being to not be conscious and somehow have free will because, and this is based on some assumptions, and these assumptions are that free will is itself an emergent phenomenon from consciousness. It's not that. So consciousness is itself. You can think of it as operating at a lower level relative to free will. So free will is even at an even higher level. It's a higher level of abstraction, which the universe has created.
But I think you contradicted yourself because like if you said you needed consciousness to have that higher level perspective. So do you need the consciousness to have the free will then?
No, because you can realize the free will in a different way. I don't know what that way would be, like, but in theory, like if free will is strongly emergent,
it could be self-aware and like somehow reprogram itself.
Actually, that would be a good example. Actually, like you program free will into it because it has the ability to code itself, something like that. Like maybe it doesn't experience, but then you get something that's equivalent to free will, the same way humans can like program their own brains using their free will. Like I can program my brain to be my neurons to be good at playing guitar by using my consciousness and my will to direct myself towards that. So I can reprogram myself literally at the neurological level using my consciousness. And so I'm using my free will rather. And that's an example of a top-down effect. And so assuming it's multiply realizable, that free will is multiply realizable, it's possible.
That's the word I keep forgetting. Multiple realizability.
Yeah. And assuming that free will is strongly emergent, you could possibly get it in a completely different arrangement that doesn't involve consciousness. And the way you mentioned it sounds pretty like a very interesting way, like a computer program that somehow self-programs.
Yeah, even if it isn't wired in any way, shape, or form similarly to how we would imagine it creating a conscious experience. Yeah, that's a terrifying thought.
That's utterly terrifying. I mean, okay, so the thing is, like, I think at the end of my presentation, like, I wrote a note, and it was very, like, half-baked, but let me go to it, where, like, I said that, like, things like LLMs, large language models, like, they seem to be examples of, like, super strong emergence, like, phenomena that are so crazily emergent that our brains kind of, like, that we don't even, like, we're still interacting with ChatGPT, and we're still not really making sense of what's going on. And, like, it's doing things, it's giving us outputs that are just really unexpected. And so like I would say that this is an example of an emergent phenomenon that's just going so much. And again, emergent phenomena, they don't have to, like, the different levels of emergence don't have to be in the same direction, let's say. You can get like phenomena that are completely so for example, I would say gravity, and I could probably prove it if you just give me enough time. Gravity is strongly emergent relative to quantum mechanics. But you see how gravity is like a higher level phenomenon, but it's not like consciousness, right? Like it's a different type of phenomenon. It's completely tangential to consciousness. And yet I would say both are strongly emergent. So like you can get strongly emergent phenomena that are completely on a different level and completely irrelevant to other strongly emergent phenomena. And that's what makes the universe so weird, is that like you can get strongly emergent phenomena in completely different domains that have nothing to do with each other. But yeah, so I was thinking of things like the internet as being strongly emergent, because what is the internet? The internet is a bunch of computers connected like through wires that go overseas and whatnot. Perhaps you can give a more elegant description of it than that.
That's fine. That's good.
Okay, yeah, but like you can see how it's composed of multiple computers, and so it's made up of multiple computers, and so it must be emergent in that sense. But then like what it does is like completely new. Like us having this conversation is like a completely new thing that's enabled by the internet. And in that sense is, I guess, novel.
Sure. It's
described in
like
some sense.
it's like us talking about poison ivy. Like
Right.
we're on the internet, discussing the internet, and now we can go and apply our knowledge to make the internet bigger and different and more informative. And yeah, our top down conversation and perspective on it is going to change it fundamentally from the bottom up. I see what you're saying.
Yeah, but
It's definitely like an interesting and like relevant like thing to think about as far as like as far as emergence goes. And again, it does seem like strongly emergent things are more common than weakly emergent things.
Yeah.
Which it seems backwards, but
well. Okay, hold on. If I could reconvince you that like okay, I need to look into this more to like see if there's any examples of weak emergence that are strictly weak and not related to strong emergence. But like you can argue that weak emergence is literally anything, and then strong emergence is just when that top down thing happens. And again, like, do you understand what I mean by like you can talk about weak emergence within certain systems? Like I could talk about like the theory of economics, right? Like economics has a whole bunch of different principles, and I can use those principles to predict what's going to happen in economics, and those predictions will make sense, and in some sense be weakly emergent in the domain of economics, even though economics itself is strongly emergent relative to the fundamental level. Does that make sense?
yes. Okay, so you're the concept itself is weakly emergent, but it doesn't actually cause any effect.
Yeah. Like it in of itself doesn't compose like a new thing that has an effect. But once it does, that's when you have strong emergence. But I would say like even that process of getting to that phenomenon was weakly emergent, and then it just kind of like it triggers that threshold, and then now it's strongly emergent. Although, like I'm not always a fan of threshold theories because it kind of like makes things dichotomous, and clearly things aren't dichotomous.
Yeah, but sometimes they are though.
But sometimes they are.
Like,
Yeah.
sometimes there is that critical mass thing, like where something like it is that like that weird baldness thing where it's like, okay, you have a proton
Yeah. It just tips the scales.
or whatever it is, you're now this, so yeah.
Yeah. What else is interesting or fascinating about this whole thing?
Everything.
Everything. It relates to everything. It's about everything. We literally had a conversation about everything. I mean, like I think the most. I don't know if this is it's really subjective, but the thing that really like makes me interested in all this is biology. And then like I just want to, now knowing what I know about this, I just want to like study every single plant, because every single plant firstly is strongly emergent, and like you should be fascinated. Like we should be like we realistically should be outside in nature staring at trees all day, because what the fuck is going on? Like it's so bizarre that this even happens on our planet, and the reason we don't treat it like it's so bizarre is because we're so used to it. Like we're born into the world and we see it and we perceive it as it is, and so it just seems like it seems ordinary to us. But if you
it gets beat out of you.
Yeah, and that makes sense.
It gets beaten out of you.
Yeah, that's totally reasonable.
You gotta have responsibilities. You can't just be smelling the roses all the time.
I wish people were more in the smell the roses mood more often. But I guess you're right. Like we get distracted from living and existing as humans. But different like phenomena in biology, and like if you just like think about like an insect, and like the different like forms of that insect you'll find in nature because of evolution. And like all of these different forms, like they may evince different properties. Like they may have different properties. Like you look at a butterfly, like a genus of butterfly, and then look at all the species that are connected to that genus, and then you might find that every single one of those species has a different like ability or different property. And like this is what's being implied by emergence, is that like you can get completely different things existing in the universe. Like a good example would be like an electric eel. Like an electric eel is a crazy animal. Like how did that even happen? but it exists, and it started to exist in our universe. And like now there's this being that has this property of being able to produce electric currents that can shock other living beings. Like it's bonkers.
Pretty wild. Yeah, it's pretty wild. And from my perspective, what I think a lot about with this is invention, and engineering. And I mean, because all of this applies to pretty much any invention, like the plow, for instance, had such an intense top-down effect on how human beings interact with the world in general. I mean, it had like it turned us from a nomadic into an agricultural ape, and yeah, I mean, so many things are like that. The printing press, which is an extension of what we were talking about with language being in this category also. So, I mean, humans are like the effect that you're talking about, just on steroids, and we can do a bunch of sounds at each other and somehow coordinate like a new effect, literally a new emergent thing, like over the internet, which we also invented and created and is emergent.
Yeah, I really like that, the way you put it. Like, humans are like this on another level. Like, that's so true. As humans, like the technology that we're producing and like the fact that we can speak and the fact that we're conscious, like at this level, like these are all like crazily emergent phenomena from the lower levels, and that's why a human is that's why like I feel like people should just believe in free will on default, because a human is such a complex system that there's no way the universe's trajectory makes sense with humans in it, or like is predictable with humans in it. Humans themselves are like very unpredictable. And not only that, we can generate our own randomness like within our heads. And like we're also subject to random processes. So there's no way you could predict what's going to happen in the universe just from looking at our particles. We ourselves are like something new, something crazily new. And like that should be apparent to anybody who like spends any time thinking about what it is to be a human.
Yeah, that's why I liked your like how you tied this into free will. And I kind of like, my perspective on this particular subject is, I mean, I've talked about Schopenhauer before. I pretty much, I mean, I follow his philosophy, and that basically everything we interact with, all of creation, is will is representation. And whereas like everything is constituted in some sense of this unforced will, humans have the uniqueness through that emergent property of free will. And so it's like the will and like that randomness, that X factor, the Joker card that's kind of like baked into every single thing that exists, is what produces the randomness and new properties of emergence. And then human beings take it to the next level where they can consciously choose what things we want to emerge. And so, I mean, to an extent, we can't know, and that's what's interesting too. We can have like when I invent something, I have a vision of it in my mind, and then like I have an idea of what properties it's going to have, but until I actually build it, and sometimes it has new emergent properties I didn't anticipate, and just like my buddy, inventing that quantum filament, he didn't foresee it. He did it and observed it, and now it's a new thing.
I mean, I would say even like if you could use your mind to, so like obviously transistors and what they can do wasn't like, we didn't like arbitrarily put this together and then like, oh my God, like it does math, like how unexpected. Like we designed them to do math. But I would say that like we designed them using our higher knowledge, our consciousness of like the properties of crystals. And then we arranged them such that this configuration had never existed before. And then like, even though we predicted the properties beforehand, it's like the universe couldn't have predicted those properties, let's say, if that makes sense.
Yeah. And it didn't, and it didn't predict it, and it also didn't produce it without like previously emergent properties.
Exactly. Yeah.
I.e. the humans.
Yeah.
So yeah, it's wild shit.
Yeah,
it's definitely cool. I think that I really got to pee, so I think we got to
we'll wrap it up.
Probably cut it short now. But I think we should maybe revisit it shortly, because there's plenty to talk about here with this.
Yeah,
so.
Yeah. I'll revisit this.
It is deeply interesting to me. So
yeah, that's good. And hopefully it's been interesting to everybody watching. But okay, yeah, I guess we'll wrap it up there. Thanks so much, Dusty, for your time, and let's definitely try to do this again in the future.
All right, sounds good, T-Pan. Thank you. Have a good one, man.
You too. Take care.